Hey, Jonathan here at Colfax Math. Working on some Math SL from the Oxford textbook. This is an IB Math course, and specifically in this video I'm going to go over section 12.3 trig, equations, and identities. Traditionally one of the hardest sections in trigonometry, but very useful in all other math classes. But you do have to put all your skills together from all your algebra classes and all your trig skills together. Let's go ahead and get started. So I'm on trig identities and equations. I would highly recommend you read this and that on your own time you go through investigation 4, and you got to go kind of slow and really work your way through this investigation. These trig identities are hard. But a couple of the big ideas here is if I have a problem like sine of 30 degrees, this is an independent variable, an angle, a measure, there's only one corresponding answer to that. So if sine of 30 is I rotate around 30 degrees, I create a triangle. Sine is opposite over hypotenuse. I recognize that as a 30, 60, 90 triangle, and my answer is 1 over 2. If it were in the second quadrant with the same reference, like sine of 150 degrees, it would give me the same ratio of sides. But my point is here is given an independent variable theta, there's only one corresponding answer, and it's a ratio of sides. However, if this is the problem, sine of theta is equal to 1/2, and I'm asking you what angle will give me this, well, there's an infinite series of angles that'll give you that. So right here, I could have an opposite of 1, hypotenuse of 2, and an angle of 30, so that would be a solution. Or over here, an angle of 150 would still give me a 1 over 2, so that would be a solution. Or I could start right here and rotate around 360 plus 30, so 390 would be a solution. Or I could go around 360 plus 150, 510 would be a solution. Or I could write the general solution as 30 plus 360n, and 150 at 360n. So that's the general solution given a dependent variable looking for an independent variable. I'll just go on a little bit of a tangent here. If I were to graph that sine graph, it would cycle in 360 degrees, but it would keep going in both directions forever. It has a height of 1, a low of -1. If I'm saying what is the ratio of sides at 30 degrees, I just go up and I read that at 0.5. However, if I'm given a y value, a dependent value at 0.5, what's the solution? Well, it's all of these values, the 30, the 150, the 390, the 510, all of those are my solutions. So that's maybe one of the biggest ideas in solving these equations. The next is you have to be able to know if it's exact value or approximate. Exact means without a calculator. Approximate is with a calculator. Then you have to differentiate between radian measure and degree measure. So some of these are in degrees, some of them are in radians. If you look at the domain, that's kind of the giveaway. And then the last piece is once you solve that problem, then you want to make sure all your solutions are in the given domain. Okay, so starting on section 12D, we're going to start solving trig equations. The first one here is cosine of theta equals 0.6. And even though that looks like a decimal, it's still a ratio of sides. It's either 0.6 to 1, or 6 to 10, or 60 to 100. So it's saying I have a triangle where my adjacent leg is in a ratio of 0.6 when my hypotenuse is 1, right? The cosine part is telling me adjacent to hypotenuse. And it could be 0.6 to 1 or any of these other ratios as long as they're the same. So I know, like I was saying before, that there's infinite series of solutions for theta when I'm given a ratio of sides. So here in the directions, it's not asking you to find all solutions. It's only asking you to find solutions between 0 and 360. So the question is, it happens in the first quadrant, all students take calculus. It also happens down here in the fourth quadrant where the adjacent's 0.6 and the hypotenuse is 1. There's no little exact value notation here, so I'm going to do it on my calculator. First thing I do on my calculator is I make sure I'm in degrees, so I'm in degree mode, and then I go second cosine of 0.6, and I get 53 degrees. So my first answer is 53 degrees. So here, theta is equal to the arc cosine of 0.6. Theta is equal to 53 degrees. And it's also equal to 53 degrees in the fourth quadrant. So I rotate around 53 degrees less than 360. So it's also going to happen at 307 degrees. And it's going to happen again 360 plus 53, but that's outside of my domain. So probably the most important thing to note here is that, I know I say this a lot, but given a ratio of sides, you have an infinite series of solutions. These number 2 is kind of the same. Number 3, you have kind of this complicated equation here. So on number 3, you have 2 sine squared of theta plus 5 sine of theta equals 3. So the first thing I'm going to do on this, and you're solving for theta with a domain between 0 and 2 pi, so we're in radians. So I have 2 sine squared of theta plus 5 sine of theta. I'll subtract 3 from both sides, set it equal to 0. This thing's starting to look like a quadratic, right? It's starting to look like 2x squared plus 5x minus 3 equals 0. 3 ways to solve a quadratic. One is to factor. Second is a quadratic formula. The third is to complete the square. So if I'm looking at this quadratic here, I'd factor it as 2x and x. Factors of 3 to give me a 5 would be a 3 here, a 1 here. 1 has to be positive, 1 negative. This one will be positive, this one negative. And I'd set that equal to 0. Let me double check that. The reverse of factoring is foiling it out. First, 2x squared minus 1x plus 6x gives me 5x minus 3 equals 0. Zero sum property, 2 quantities multiplied together equals 0 means either 2x minus 1 equals 0 or x plus 3 equals 0. Add 1 to both sides. 2x is equal to 1. Divide both sides by 2. Or x is equal to negative 3. 2 solutions. I do the same thing here. I'm going to factor this to be 2 sine of theta minus 1 times sine of theta plus 3 equals 0, leaving me with sine of theta equals a half. Right, 2 sine of theta minus 1 equals 0. Add 1 to both sides, divide both sides by 2. Or sine of theta plus 3 equals 0. So that's going to give me an empty set. This is going to happen where the opposite is 1, hypotenuse is 2 in the first quadrant. And it's also going to happen here in the second quadrant with the 30 reference. So problem asks for a domain, even though it says theta, I guess it should be x, but 0 to 2 pi. That's going to happen at 30 degrees, pi over 6, and 150 degrees, 5 pi over 6. So that's how you do number 3. These aren't easy. You need a lot of background before you go into these. I'm really happy to review these again because this is some of the most important skills that you take out of an integrated 3-class pre-calc trig class for calc. Number 4, this is a little bit of a hard problem, but I'm solving again. I have 4 cosine of theta, here it's x, minus 3 sine of x equals 0. I think I'm actually going to do a separate video on this one. I'll just tell you this to get started on it. You're going to add 3 sine of x to both sides. And then if I divide both sides by cosine, I'm going to have sine over cosine, which is a tangent. But I think I'll do a separate video on this. And then I can divide both sides by 3. And then I'm going to have sine over cosine, which is tangent. And that's going to equal 4/3. So that should hopefully be enough to get started on it. And then I'll do a follow-up video where I just solve this one problem here. This is Jonathan, Colfax Math. Hopefully this is helping you. This is IB Math SL, Trigonometry.